Patimura University.
Hello guys, welcome back to our channel. Now I will explain about isotropic soil. Apologize if there are many shortcomings and if you are not understand, I'm sorry. Homogenesis and isotropic. For engineer students, of course, the two words in the title of this paper are not foreign, especially to explain a material condition. However, sometimes students cannot explain the definition of homogeneous material and isotropic materials. Homogeneous materials is a material whose composition is the same in all arrays. Just imagine a homogeneous community of people. Well, in that community, the contents are the same as everyone. Isotropic material is a material that has similar properties when it is loud from different directions. So homogeneous and isotropic are different, right? But I'm not talking about being homogeneous, but about isotropic. Okay, in Wikipedia, isotropic is uniformity or uniformity in all directions, derived from the Greek word isos, equivalent, and tropes. The exact definition depends on the subject area exceptions or inequalities, often indexed by the addition of the prefix and become anisotropy. Anisotropy is also used to express situation for systematic difference traits. Depending on direction, isotropic radiation has the same intensity regardless of the direction of measurement, and isotropic fields produce the same action regardless of the orientation of the particles being tested. So isotropic material have the same material properties in all directions. There is not effect or on orientation or crystallisis. Anisotropic soil is a homogeneous land which has a flow of key not equal in all direction. Depends on the permeability. The soil is assumed to be anisotropic, although homogeneous. Most of the soil layer is indeed anisotropic with a maximum permeability coefficient when the flow direction is parallel to the layer and the minimum of the direction is perpendicular to the layer. The direction of the flow are denoted by X and Z respectively. Namely, is in the case the general from Darcy law becomes likewise for directions which forms the angle at the broader x-axis. The permeability coefficient is defined by the equation now. EA, the components of the flow velocity are also connected as follows. Based on the general form of Darcy's law, the continuity equation can be written as follows. Or substitution, the continuity equation becomes with a continuity equation for isotropic soils. in the XZ plane, thus it produces a scale factor on the S-axis to the transform the anisotropic flow area into the isotropic stream, where the Laplace equation can apply if the flow network for the transformation area has been drawn. Then the flow network for the actual radiation can also be drawn using the opposite of the Shackle factor above. However, usually the important data is obtained from a cross section of the transmission. The transformation can also be done in the Z direction, the permeability coefficient applies to the transformation section is expressed as to the load. It's my explanation from me. I apologize if there are many shortcomings. Okay, thank you for watching.
Baca.